Read the question carefully. Here we got a rectangular storage with an open top is to have a volume of 10 cubic meters. So that's the constraint. So volume must be 10 cubic meters. Okay, constraint. And we got a rectangular storage container with an open top. It's always good to draw a diagram, so it doesn't have to be perfect. Okay, something like this. So rectangle in each side. So open top, there is nothing on the top. That means we have 5 sides: front, back, right, left, and the bottom. And the volume of this box has to be 10. So volume means length times width times height. So we'll get back that in a moment once we assign the variables. The length of its base, let's say this length is twice the width. Oh, this is width and this is height. So length is twice the width. Means if we assume width x, then this will be 2x because length is twice the width. Now it says material for the base costs $8 per square meter. So material for the base. So base is here, 2x length with x. So when we are trying to construct this container, rectangular container, the base material costs $8 per square meter. Material for the sides costs $6 per square meter. Find the cost of the materials. That's the cost is objective function, by the way. We need to determine the cost. Objective function for the cheapest such container, and we want to minimize the cost. Okay, so we need to minimize. So we already assumed width. So let width of the storage container be x, then length will be 2x. We have height as well, so let's say the height is y. Okay, constraint, that is the relationship between these variables. Volume has to have 10. So volume means length times width times height. So I don't have to write volume. I know how to find volume here. 2x times x times y equals 10, which is 2x square y equals 10. And as soon as we write the constraint, we want to solve this for one variable. So x square y, let's solve for y, easier. That means we divide by 2x square. So this implies y equals 10 over 2x square. That is same as 5 over x square. Later, as soon as we find the value of x, we come back here and find the corresponding value of y. Okay, next is the objective function, and that we want to minimize in this case. That happens to be the cost. So we can write on C, or you can write even F, it does not matter. Let's determine the cost to construct this rectangular container. So base costs $8 per square meter. Square meter means pretty much we are trying to find the area and multiply by 8. So area of base is what? 2x times x. So 8, that's the per square meter, times area of base is length times width, means 2x times x. Plus, let's look at the front and back. Front is here, so let me use different color just to front and back are same. So this is 2x, this is y. Okay, and that costs $6 per square meter. In fact, for everything else, so we can multiply by 6 times the area of other sides. So front is 2x times y, and back is also same 2x. So this is 2xy, front is 2xy, and back is also 2xy. So 2xy plus 2xy, we can write 4xy. That's the front and back together, plus right and left. And let's look at right. So right is here. I mean, this one is pretty much a rectangle. We have this x and this is y, so xy. So this is xy, this is also xy on the left, because right and left are same. Xy, how many xy's? 2xy. So this is the objective function, this is the cost function we want to minimize, and there is no top. Okay, so we don't have to worry about this part. Let's write this objective function in terms of one variable. This is in fact using this constraint, 16x squared plus 4xy plus 2xy. In fact, this is 6xy. 6xy times 6 times 6xy. Okay, we have two variables here, x and y. Now we replace y by the constraint here. Okay, that means this is 16x squared plus 6 times 6, 36x, times y is 5 over x squared, and we can simplify further. 16x squared plus we can cancel one copy of x from top and bottom. That gives 36 times 5, 180 over x. Okay, now this is our objective function in terms of only one variable, and we want to minimize the cost, means minimize this function. And always to minimize or maximize, we first find the critical numbers. We find the derivative, in this case cost, this function derivative, that is 32x. And by the way, for this one you may use quotient rule to find the derivative, or this is 180 times 1 over x and go from there, or use quotient rule. The derivative of 180 over x is negative 180 over x squared. Okay, you can check using your quotient rule. Then we set the derivative 0 to find critical numbers. That is 32x minus 180 over x squared equals 0. We got only two terms and 0. Move this fraction to the other side. So I'm going to write here 32x equals 180 over x squared. Okay, this over 1, by the way. Now we can cross multiply. I'm trying to solve for x. So 32x is x and 32x cubed. Oh, this implies 32x cubed is 180. Okay, now divide by 32 and take cube root. So x cubed is, so let me write over here. Okay, that this implies x cubed is 180 over 32. Okay, and now we can simplify this and take the cube root. So we found x equals, take the cube root. In fact, we can simplify. 4 goes 8 times, 4 goes 45. So we got x equals cube root. Cube means cube root of 45 over 8. If you punch this in your calculator, 45 over 8 and take a cube root, so it comes out to be about 1.77. Okay, so this is part of our answer. We are supposed to find the cost, and the cost is here. Okay, all we have to do is now plug in x equals this number here and get the cost. But how do we know this cost? This makes x equals this makes this cost minimum. Okay, to show x equals this number, which is about 1.77, makes the cost the lowest or minimum. Let's find second derivative. So we got here first derivative. Okay, second derivative is, what is the derivative of 32x? Just 32 minus 180 over x square. So 180 over x square means like this, 180 derivative negative 2 negative 3. So negative means this is positive, 360 over x cube, or you may use quotient rule like earlier. In any case, this is our derivative. Okay, and for x positive, because this is a positive value, for any x positive, this is always positive, and there is no negative. 32 plus 360 over x cube, this is always positive, implies the curve, the cost function curve is concave up. Second derivative positive means concave up, and our critical number that locates minimum cost. That implies x equals this junk. Okay, minimizes the function. Minimizes the function means the cost function. Okay, thus the lowest cost or minimum cost, okay, my bad, minimum cost. So go back and plug in into the cost function, okay, which is here 16x squared plus 180 over x. Okay, that is 16x squared cube root of 45 over 8 quantity square plus 180 over cube root of 45 over 8. Okay, and you may leave here that many dollars pretty much. Okay, cost means in terms of dollars, or this comes out to be 151, about 151.82 final.